So when you're looking at the spectrum of stars, remember the spectral types O, B, A, F, G, K, and M, and that is going from the hottest to the coolest. So this is hotter that way, cooler that way. Way you tell the spectral types is by looking at the particular spectral lines. And so there's different ways of doing that. The way that I learned to do it when I was a student was you look at a photograph of the spectrum and you look at the spectral lines. Nowadays, astronomy students learn to do it with intensity line trace, where you're measuring how bright the light is, and the dips here correspond to the what look like dark lines up there. Either way, you learn to recognize the pattern. Each element has its own unique pattern, like a fingerprint, and so you can recognize the pattern. And so O stars, because they're super hot, they tend to ionize helium. Now, in the elements up here where it says He1, that's neutral helium. If you take away one of the electrons in a helium, it behaves differently, and that's He2. That's ionized helium. And so you get different spectral lines. B-type stars, they'll typically have more hydrogen than the O stars in them, and they'll have neutral helium, whereas you have a little bit of neutral helium in here, whereas the O stars have ionized helium. And then you get down into the A's and F's, and you have over here some lines which are actually calcium-2. So that's ionized calcium spectrum. You get down here for the really cool stars, and you have neutral sodium spectral lines. And so what happens is, over practice, astronomers just kind of get used to recognizing these patterns and recognizing what the different spectral lines are. And so you look at the spectral lines, and that tells you the spectral type. Now, why go to all this trouble when we know that there's a formula by measuring the peak wavelength, you can find the temperature. In this case, each spectral type corresponds to a temperature. So this turns out to be better than the other way, because interstellar dust and interstellar medium, stuff that's between us and the stars, actually affects the color of the star, but it does not affect the spectral lines. Again, what you would do is you make graphs here and there that show which spectral lines are most obvious in which parts of the spectrum. And so you just find proportions of them and you figure out what they are. Now, O, B, A, F, G, K, M. These are the spectral types that Annie Cannon had come up with. But towards the end of 20th century, astronomers with new telescopes that could see dimmer things were seeing dimmer stars, and stars that were so dim that they typically didn't shine very bright because they were very cool. Remember, how bright something is depends on how big it is and how hot it is. So the cool stars tend to be not very bright, and so these cooler stars were so dim, so they added a new spectral type, L. And then eventually added another spectral type, T, here. And so L and T. And so the L stars are super cool stars. They're barely even stars. The T stars are actually failed stars. These are things that don't even make it into stars. They're things that form like stars, but they don't really ignite like a star. They just gradually cool off, and they're just super cool. They're actually giving off mostly infrared light, not visual light at all. And then in 2013, there's about a handful of objects that are even dimmer than dead or rather failed stars. And so these are things that are basically just glowing blobs of infrared, warm gas. And so they introduced another spectral type, Y. So that kind of messes up our mnemonic, O, B, A, F, G, K, M. I guess it could be, "Oh, be a fine girl, kiss me later tonight, Yvette," or something. I don't know what, but however you can think of a mnemonic to help remember the order is useful because you need to know what order these things come in order to figure out hot and cool and so on. So here's kind of a graphic right here that shows you the different spectral types, kind of what color star that would be, temperature range, what kind of things you would look for if you were actually doing spectral classification, and then examples here of some of these.